Hello and welcome to the Tuesday, August 2nd, 2022 edition of the SANS and its Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. Today I wrote a quick summary of a small distributed denial of service attack, a DDoS attack that caused some performance issues in a short amount of downtime on Friday morning. The attack was not very intense, even though about 100,000 IP addresses participated in it, but each IP address individually did not really send a ton of requests. I think we sort of ended up with about a dozen requests a second, so nothing really all that extraordinary. This is actually kind of a typical sort of small denial of service attack, as many small sites tend to experience them from time to time. So given that, I took the opportunity to walk through the process we used to bring our site back online, even with the attack still ongoing. What made the attack a bit more tricky was that it involved valid HTTP requests. So this wasn't just the flooding random packets, and it hit a page on our site that takes significant database resources to create. So someone went through the effort to actually catalog the page on our site, figure out which page takes a lot of resources, and then what was actually exhausted was database resources, not bandwidth, as in some of the simpler denial of service attacks. But, well, of course, once we knew this and once we identified these requests, then all we really had to do is block them with our web application firewall, and that sort of took care of it. Now, when on an attack like this, the tricky part is often identifying the common artifact that distinguishes attack traffic from normal traffic. In this case, the artifacts were that all source IP addresses were located in China and that one particular URL was hit. And often you end up refining these filters incrementally. When we first looked at it, it looked like the user agent was a good filter to go for. They used a very specific user agent. It was a slightly outdated version of Google Chrome, but then again, it was also used by legitimate requests. So that's when we tried the other filter. But the initial filter was still useful. It brought the site back up and did help us sort of get back into business, essentially, and also then bought us a little bit time to investigate further. Now, once the block was in place, everything went well. The attack itself actually continued throughout the weekend and then stopped Monday morning, I guess, when whoever started got back in the office. They figured out it no longer worked. And a CloudSec report looked at applications that leak Twitter API keys. If you register as a developer with Twitter, you have the ability to create consumer keys and secrets that enable you to authenticate to Twitter. These credentials are linked to a particular user, and if they're leaked, then of course anybody can use them to perform actions as this user. So you should actually never include those keys in software that you are releasing. In this particular case, they looked at mobile applications. Instead, well, they're meant to sort of stay on the server. Now, if you do need to perform authenticated actions via some kind of Twitter client that is installed on a user's device, then well, you should just use that user's credentials and OAuth and such to derive the respective key pairs. CloudSec found about 5,000 different key pairs being leaked. 3,000 of them approximately appear to be still valid. And then, of course, someone could have used them to perform actions on behalf of the companies that leaked those keys to build botnets or whatever, or just spread this information. Yes, anybody can get those keys, so an attacker could very well just set up an account with Twitter, but Twitter does do some vetting. It takes a while to get the keys, and of course, once they see abuse, they'll revoke them, so much easier to use someone else's keys and have them go through the trouble to actually obtaining them. And the common joke among security professionals you probably heard of is that you can't attack a system if it's disconnected from the network, turned off, and encased in concrete at the bottom of the ocean. But of course, what if you skip one of those steps? And Cisco's Thales research team looked at the TCL LinkHub mesh network devices, which, at least from an admin point of view, are not directly reachable via the internet. Instead, you're using a mobile application. You have to be close to the device in order to manage it. Well, still, they were able to find 17 different vulnerabilities, from buffer overflows, lack of authentication, of course, and then also some simple command injection vulnerabilities. They did use for this device not exactly custom protocol, but something based on the protobuffer library, so not HTTP and such. If you're using that library in any of your projects, take a look at the bugs, because much of it is sort of misuse of that particular library. And then finally, we got another update from Jenkins for a good number of plugins for Jenkins. If you use Jenkins, take a look and update appropriately if you're using any of these plugins. The GitHub one sort of stuck out as something that probably a lot of people are using. Also noteworthy that some of the announced vulnerabilities are not actually being patched yet. Some of them are, I guess, in sort of more legacy plugins, like they haven't been updated in a few years and have a fairly small user base. Well, and that's it for today. Thanks again for listening. And if you have any feedback, if there's a story that I should have covered, well, please let me know. Thanks, and talk to you again tomorrow. Bye.